Good Friday afternoon, evening, whatever you wish it to be. That's where we're at today, right?
That's where we are. It's almost
All right.
weekend, depending on where you are.
For our people in Australia, it's already the weekend. Yay.
Makes you want to be there.
Except their Monday comes a lot earlier. That's the problem. But that's the only problem with Australia. Actually, Vegemite, not my favorite. Hi, by the way, my name is Darren. This is Victor over here. We are the co-host of DevOps Paradox. It's a podcast about DevOps and other strange and wonderful things. Some days. And today is Friday. Feels like we just did this, doesn't it?
Because we just did it yesterday.
Yesterday, which we had a special guest yesterday. So if you are watching now or watching the replay, go back and watch the stream that we did with Adam Sandor. That was on July 2nd. Today is July 3rd, by the way, just in case you're wondering. And we have a weekly podcast. We said all the things, and this is the live part of this. So this doesn't come out as a podcast. This is purely on YouTube, at least for now. So today we have another guest, and let's go ahead and bring him in. It's Miko. Miko was with us a couple of weeks ago on the podcast, 2 weeks ago. Hey, Miko.
Hey, how are you doing?
Oh, wait. Do you have a drink? Did you bring a drink?
I do. I have a cup of nice green tea.
Green tea.
Yeah.
Green tea. Well, I have a soda.
You can't judge people.
Well, that's good, right? I mean, I'm glad you have green tea, but you're the healthiest of the three of us here. So I meant to talk to you about this before, but that's okay. So Friday is usually when we break out the adult drinks. In my case, the adult drink is a Coke Zero cherry.
Very mature.
Yeah, well, we'll see. So in case you haven't listened to the episode with Miko, Miko is the creator of PowerfulSeal. Do you say it as one word or two words? I just said it sort of as two words.
Whichever is fine. I tend to say PowerfulSeal as a one thing.
Okay. Because
you're a mature person drinking Coke, so you're all good.
I can already see where this is going today. That's good. That's good. So we brought Miko on today. By the way, Miko has a book coming out. It is currently available for pre-order right now on Manning and probably anywhere else. I haven't checked. Sorry, Manning, if you're watching. It's called Chaos Engineering Crash Test Your Applications. All you have to do is go out to Manning and search for Chaos Engineering. I believe Miko's book is the only one that comes up. But,
it is, yeah.
But by the way, because you're watching this or you've listened to the podcast, if you use the discount code PODParadox, the number 2 and the number 0, you get a 40% discount. It's a sweet deal. And we'll bring all that back up later. But I wanted to go ahead and talk about it now so I didn't forget about it later. Because it could happen. And we've got other information about Miko and stuff later. So for right now, though, Miko is going to give us a demo. Or do we want to talk about just in case people haven't listened to the episode yet, which was episode number 61. I had to look it up.
Mm-hmm.
See, you know what your number was. I couldn't remember it because we've done 5 episodes since your release. Numbers are numbers right now. So explain to us, Miko, what PowerfulSeal is.
Sure. So PowerfulSeal, apart from a very cool name, is attractive to everybody who wants to do chaos engineering for Kubernetes. It's kind of like a self-contained solution that lets you describe steps that you want to basically execute to introduce the chaos and then do the validation. So for example, if you wanted to verify that your application is immune to some kind of failure, PowerfulSeal, you can describe a policy that will both introduce that failure for you and then validate your assumptions about that.
Cool.
Yeah.
That's the nickel tour of PowerfulSeal, which we'll actually see it here in action in a few minutes. Mm-hmm. Victor, did you have anything, or are you working on something else?
No.
Sorry. Okay.
Nothing special coming from my side.
Okay. So Miko, let's get into your first part of your demo. So I'm going to add in your screen right now. Let's make sure it comes in. There it is. And why don't you go ahead and get started and go for it. The floor is yours.
Sure. So I'm going to assume that you guys are fresh to PowerfulSeal, but I'm going to also assume that you have an idea of what Kubernetes is, because PowerfulSeal is Kubernetes specific. So first things first, where do you find your PowerfulSeal? You go onto GitHub, github/bloomberg/PowerfulSeal, and you find this very cool icon. The README is pretty short right now. We actually have a pretty sweet documentation that you can look into. That's going to bring you, all the info that you need to get started. So what I'm going to do is kind of maybe start with just setting it up and kind of hello world, and then we'll see where you guys want to go with that.
Okay, I'm going to go ahead and put your screen full screen. So we're still here, but...
Yeah, that sounds like you're going to switch your drink because you're not visible anymore.
No, I'm not switching my drink.
No?
Still the same drink.
That's fair enough. Okay, so to get you started, if you are just probably the easiest way to get started is just to run it directly from the sources. So I have here a little setup with Minikube. That's going to be our pretend Kubernetes setup. And I'm going to go ahead and I'm going to clone this repo here. And I'm going to go ahead and basically just install it. So if we go to the PowerfulSeal, I have a backup here, as you have seen, in case something goes wrong terribly, but it shouldn't. So probably, if you're not familiar with virtualenv, it's just a little package that it makes it a bit more easy to manage your Python versions and various sets of dependencies. So I'm going to go ahead and I'm going to start a virtualenv for myself. I'm going to go and activate it, bin activate, and then I'm just going to go ahead and pip install the seal in editable version directly like that. So while this is installing, PowerfulSeal initially started with trying to cover as many use cases as possible. So there are two main ways that you can kind of set things up with PowerfulSeal. One is to do things directly on Kubernetes, kind of like minimal dependencies, and introduce the chaos. We're going to see how to do that through Kubernetes itself. And the other one is to try to not give Kubernetes any head start and actually execute things through SSH. Because of the fact that on Minikube today, I don't really have any real SSH or any real machines to speak of, I'm just going to kind of demo for you the easy way. I'm just going to use the Kubernetes ones. So this is installing. As you can see, it installs a whole bunch of things because it has drivers for AWS, it has drivers for Azure, OpenStack, and GCP. So this is so that you can actually go ahead and do things like take a VM up and down and see how your cluster actually reacts to that. Okay, so my little cluster is not particularly loaded right now. I don't have much on it. I have a Hello Minikube. I have a Kubernetes dashboard. I think I should have some services too. I just updated my Minikube yesterday, and it actually works pretty nicely.
Wait, you didn't wait until 10 minutes before to update Minikube?
Yeah, I changed. I'm a new man,
good.
a different man. So I think you can do things like this right now. Kubernetes dashboard to open it in your dashboard. Open it in your browser. Or not, you may select on my space. Oh, yeah. Kube system. And where did that go? Was not file cube system. Sorry, Kubernetes dashboard. Kubernetes dashboard.
This proves that we are live right now. It's okay. It's all good.
So yeah, just kicking the tires of my little thingy. All right. So my PowerfulSeal here is installed. I have my little PowerfulSeal command. And the one thing that you're going to notice immediately is that there are different modes of operation. And sometimes that's a little bit confusing for people, so let me just get started with that. PowerfulSeal has different kind of ways of using it for different use cases. So typically, what you want to do when you start is you want to go ahead and kind of kick the tires and see what happens. And this is what the interactive mode is for. If you just type seal interactive, you're going to land up in the CLI. And you're going to have a bunch of different things that you can do here. So you can list the nodes that are being listed by your Kubernetes cluster. You can list namespaces. You can list pods for particular namespace. So for example, the things that we were just doing in kubectl, you can kind of do that. It has this funky tab completion. But what you're probably going to be most interested in doing is if I do deployments, I have my hello minikube deployment. And if you wanted to list, for example, nodes for a particular deployment, you can do it like this. You do pods for deployment, and then you do a namespace. Again, I have my completion, so I go Kubernetes dashboard, and I have my Kubernetes dashboard deployment. And I'm listing the pods. And now, if I want to kill it, I just give it a number, the number from this particular list. So every time you list the pods, it's going to kind of keep them in the cache. They can go ahead and kill it. And the reason for that, before I do that, let me just watch here. Kubectl get pods. What's the namespace? I'll just watch all of them. See that it's actually happening. So here I'm going to go ahead and type Y, and it's going to kill it for me, and it's being recreated. So this is like the very first step when you just want to get started and you want to see and kind of kick, the tires. You can do that. And already here you can see that my healing actually works. The minikube wasn't a complete scam. It actually works pretty well. Yeah, this is really what this mode is for. There's other modes. There is one called label, in which you can just, instead of running kind of imperatively PowerfulSeal and telling it, okay, break this or break that, you can label things, label particular pods, and then run PowerfulSeal to detect that within the namespaces that you care about. But the most important one and the most interesting one is the autonomous mode. And here's when the docs get actually pretty useful. We have a whole section of writing policies. So in order to describe the policies in PowerfulSeal format, you write a config in YAML format, and the config has very simple schema. You just give it a number of scenarios, and for each scenario, there's a number of steps. If you're ever wondering how to write these things, there's this automatically generated documentation for the schema. This is against what your actual policies are going to be validated. So you can see that there's a config session and a section and scenarios. And inside of scenarios, that's an array of things that have a description, name, and steps. And the steps is where things get interesting. There's a bunch of different things. We're going to take a look at them in a minute. But two big kind of groups of things that you can do are node actions and pod actions. And both have similar structure, you have matches, filters, and actions. So the big idea is kind of that you are going to match a certain group of pods, and the matchers, there are different ones. You can match by labels, you can match by deployment, or you can match by namespace. And then it goes through filters. You can filter by property, you can filter by time, you can do some probability and random selection stuff to kind of filter the subset that you want. And then for them, you do actions. And for pods, currently, the actions are weight or different checks, counts, and state. I'll demo that in a minute. And for the node actions, it's kind of a similar situation with slightly different actions. But again, because of the Minikube, I'm going to focus on the pod actions today and show you how that works. OK, so you know where to look up the documentation, but the big question is, why would you do that, right? So to kind of warm you up, I prepared this little example, which is basically the smallest one that I could think of. This is a self-contained scenario. It has some config here, which basically means that I only want to run it once, and I want to fail as quickly as anything breaks, just so that we can actually see that. And then this is an example of a scenario. So what it does is that it has a single step pod action. And inside of the pod action, I'm going to match all the pods that are in the namespace, in particular here, all namespaces. And then I'm going to go and filter that by only selecting the property that is negative, meaning not running. The things that all the matchers and filters support regex, so you can actually write this as a negative regular expression, but it's a handy kind of shortcut to see. So and then the actions is to just check that the count of whatever goes through the filters is 0. So basically what I'm doing here is I'm going to get PowerfulSeal to do the easiest validation that I could think of, list all the pods that are not in the running state and make sure that they're 0. Okay, so I have it written here in hello world. And I'm going to go ahead and actually copy it here because I have it in my backup folder. That was hello world. I'm going to copy it here, have it here. And in order to run PowerfulSeal with it, you choose autonomous mode, and you need to specify the policy file. And the policy file is hello world. When you do that, PowerfulSeal is going to go ahead. It's going to validate your schema, and then it's going to execute that scenario. So it matched our namespace, then it matched 10 pods in all the namespaces. The initial set was of length 10, and then after the selection here, where we chose all the things that were not running, we got a filter set of length 0, just like we expected. To show you that I'm not lying to you, if you remove the negative and you just try to count the number of running ones, it didn't work. Why did it not work? That is fun. That's because I'm editing the wrong file. Let me actually go ahead and modify it here. So if we just remove the negative here and rerun it, it failed, and you can see that you're going to get a message. So this is just to show you that kind of one of the things that I'm consistently fighting against is people who have heard somewhere that chaos engineering is about randomly breaking things, and it's randomly breaking things in production, and are kind of confused about the entire validation. Whereas, kind of all the value add of this entire thing comes from actually analyzing that failure and analyzing whether your assumptions were correct, right? So yeah, so maybe let's do something a little bit more interesting. I mean, this could be rewritten. It's fairly flexible. This could be rewritten, probably easier too, in a more simple manner. If I just kind of pick, now I'm realizing that this is probably not the most simple example I could think of. I could just list all the things, and I could verify that there's 10 of them, or do something like that. But let's leave that, and let's do something a little bit more interesting. I have here my demo page. Yeah, okay. So one of the things that you would typically want to do is start with the SLOs that you expect and kind of design the experiments to verify them. And one of the...
Miko, hang on a second. So define an SLO for people that don't know what an SLO is.
So SLO is a service level objective. There's a bunch of SL stars that you probably heard of, the SLAs that are kind of the most popular. Most people, when they say SLAs, they mean SLOs. But the idea is that you're going to have some kind of service level indicator, SLI, and that can be anything that can be measured, right? Anything that you care about, any feature that can be measured. So for example, let's say that number of requests per second that my application can handle, or number of errors that happen in a typical day. And then objective is to put brackets around that number and say my value, I would like it to stay within a certain range. So for example, going back to the request per second, I would like, I expect my application to be able to handle between 500 and 1,000 requests per second, right? And then service level agreement is when you actually promise someone that if the SLO is not satisfied, I'm going to do something. So if you have a cloud provider, the SLA that they might promise you are going to be some things like we're going to give you availability 99.9949 of the time, or something like that, right? But when we're working with chaos engineering, typically we work on the SLOs kind of level, right?
Yep.
So going back to that, if you are new to Kubernetes, one of the things that you're probably wondering is like, okay, so this is great. This is magic. It magically fixed itself. It detected that a pod wasn't running. And there is this kind of self-healing loop in the background, and that's great. And, we should all just sing and dance in circles. But what is not immediately clear to you is like, okay, so how long, for example, does it take for a pod to start? And this is what I prepare here to see that the deployment, if I start something, if I create a new deployment on my Kubernetes cluster, I want to wait 30 seconds, and I want to verify that after 30 seconds, I can actually access that. So this is two new functionalities of PowerfulSeal that I'm going to demo here. So again, we have the same config to fail fast and just run it once. And then we have the new step called kubectl. And kubectl quite literally uses kubectl command under the hood. It packages kubectl inside of the container, and it basically feeds it whatever you give it here. With a few nice features, like, for example, when you deploy this, after the fact, whether you succeed or not, it's going to do the cleanup for you automatically at the end, so that you're not left with things like that, and you can do apply, delete, and etc. So this is basically an equivalent of taking this stuff and putting it in a file and getting kubectl to actually apply that. So you could use it, for example, to scale something, or in my particular example here, I'm using it to create a deployment. And the deployment I'm creating here is a little bit complicated because it has the cluster role binding, and the service account here. But this is just so that I can shamelessly plug in another project that I run, which is called Goldfinger. And if you've not heard of that, it's a really cool, neat little tool. Is that enough adjectives? Cool, neat, little tool.
There's probably a few more you could use, but that's okay.
Yeah. Can we edit that later?
No.
Oh, no, this is live. That's a shame. Basically, is that big enough? Hopefully.
Yeah.
Goldfinger created Goldfinger when we were trying to get a little bit better of a handle on detecting networking issues in our fairly large Kubernetes clusters at work. So because of the fact that, at the time we were using FlannelD, and there were certain scenarios that were making us a little bit uncomfortable, we wanted a tool that would basically tell us where things are breaking. And that's what Goldfinger does. It runs as a daemon set. I modified here so that it's a deployment, just so that it's easier to manage on the Minikube. But usually, typically, you're going to have a daemon set so that it runs an instance per node. And then what it does is it queries Kubernetes, hence the service account here that it needs to actually be able to list pods in its namespace. Sorry. And then each instance is kind of creating a part of its full graph. So each instance is going to call each other instance on a regular interval, and it's going to detect whether it can't access the other one or where things slow down. And it's also because of the fact that it's continuously reading the pods from Kubernetes API, it also generates metrics for the time that it takes to ping it from that particular node. So it's kind of cool. I was surprised when I recently saw that it's actually been downloaded 1 million times. That was pretty cool. And you just drop it. It's a very small image. And then if you have Prometheus, you can mark it with the Prometheus scrape label or annotation. And it's going to generate for you the metrics that you can alert on. So anyway, that was a shameless plug. And this is the deployment that does all these things. So the service account, the cluster role, and the cluster role binding, and then the deployment. And the deployment is not particularly complicated. It's just a Goldfinger v300, 2 variables, and a service for that. And the reason why I tweaked it is that I'm using load balancer because on the Minikube here, it's actually pretty neat that you can access the IP directly so that my PowerfulSeal can hit it. So it deploys that. After that, it waits 30 seconds. And after the 30 seconds, it verifies for me through the probe, HTTP probe functionality. So this should be fairly straightforward. When you're writing your own probes, you can directly put URLs. If you wanted to, for example, resolve some kind of ingress, or if you wanted to just check some kind of external service. But for the stuff that runs on your cluster, you can just select a service with a particular namespace, and port. And it should, with a little bit of luck, get you to test that for you. So let's see how that what that looks like. PowerfulSeal. Backup. This is policy 1. I'm just going to copy it again here so we can modify that. And I was running autonomous with hello world. Now I'm going to run it with my policy 1. Boom. So I don't know if you have like an elevator music for the next 30 seconds or something while it's sleeping.
So we'll just actually here. Let's bring Victor back in.
No, you will have to sing.
Victor.
It's your code. You need to sing.
Actually, I saw the other day elevator.
No, don't play music on here. No, don't do it.
If you ever wonder.
Okay, yeah. Maybe this is okay. What is this?
That one is actually cool. I saw it the other day.
it plays the music in the background while it's while it's scrolling up. It's amazing.
Okay.
Anyway, so the 30 seconds went past. I'm gonna kill it, and as you can see here, it created all the things for me through Kubernetes, through kubectl. Then it made the call. It resolved my little service here. It resolved the half-z. I should be able to open that, I think, with my tunnel. Oh no, sorry. I just deleted that. Yeah, because it validated and did the cleanup, so it's all gone now. As you can see here, it created the Goldfinger, it validated it, and it terminated that. So this is, like a fairly good example of what you might actually want to be doing. If you are unsure, for example, how long it takes, there's a few different variables that go into that, whether, how big the image is, whether it was already on the host and stuff like that. But there should be some kind of SLO that whoever is providing you with the Kubernetes cluster is going to give you, and this is how you can verify that. And again, just so that, I'm not lying to you, I'm actually curious whether, let's see. Jesus, it's so much harder to type when you're
standing
in front of people. So if we change it to 1 second, that should be enough to make it fail, so that you can see that, hopefully I'm not lying to you too much. Shit. Oh, no. Okay, yeah. For a moment then I was worried I was quick enough. So yeah, you can see the cleanup too after the thing died. Okay, so that's like, the start that I wanted to kind of cover with you.
Yeah.
What else did I have here? The demo. Oh yeah. So the next thing that you probably want to do after that, I know how we're doing time-wise. Do you want me to go a bit further? Do you have questions? Do you want to go kind of steer it somewhere?
Victor, do you have any questions?
Or do you want you can. I think you can continue with the plan.
All right, stay with the plan.
Stay with the plan.
Next.
Yeah, it's usually, I was expecting you to be interrupting me, but that's fine.
I felt bad because
well behaved today.
No, I was interrupting you so much last time we spoke that I kind of trying to repent for the sins.
Nice. Yeah, so you're repenting. That's cool. Okay. So let's do something. Let's try to modify that now, this policy here, to see. Let's save it in my. This one, let's do policy 2, YAML. And I mentioned here that, one of the things that you probably want to be doing is that, let's say that, this is my application, right? So if I just kind of get it to start it and then I kill it, yeah, it created for me the Goldfinger stuff, right? So I have now a single deployment that's almost ready. Come on. That's kind of weird. Good pods. Still running. Why is it showing us not ready? Ah, there we go. So one of the things that we might want to do, I have the service, right? And this is the minikube thing that I wanted to actually use beforehand, Goldfinger, at the beginning. This is what it looks like. It's a graph, but let's be honest, it is not the most exciting graph, right?
It's a graph of 1. That's what I would expect.
It is a graph of 1. Yeah, yes. I mean, it's not the worst, right?
Yeah. It's what we expect, so that's good.
Yeah. So one of the things that you might want to do is you might want to scale it, right? So if I go ahead directly on my little kubectl, if I scale my deploy, Goldfinger replicas. If I do 3, right, I should have them coming up sometime soon. and my graph hopefully starts to look a little bit better. It's showing here. So this is how it's showing when it can't connect on the graph. So it makes a connection by default every 30 seconds. So this red thing should hopefully go away within 30 seconds, or maybe not. This is interesting. It can't connect to itself. I assume that that's probably because of the Minikube stuff. Other cool thing is that you can actually see a heat map. So if you have like a bigger cluster, this is 3x3. If you have a bigger cluster, you're going to probably see which nodes are a bit more busy in terms of connectivity. Okay, so let me scale that back to 1. And the pod's going away. Boom, boom. Now there's an issue about someone who didn't like the stuff will be there soon. So that's probably gonna go. Anyway, so this is the application that we just deployed. So I'm gonna just go ahead and I'm going to do something, add basically to this policy. So we have the 30 seconds. We know that we can help see the stuff out of it. So instead of doing just a single replica, what I'm going to do is I'm going to do 2 replicas. And then what we're gonna do is we're gonna steal something from the examples here. This is something that I just kind of wanted to point out because I'm pretty kind of proud of the docs that we actually have now. So if you go to verifying the pod status, for example, no, wait, which one was that? Deployment redundancy. You can see an example of how you can kill stuff. So I'm just going to go ahead, copy it here, paste it here. So this is a pod action. I'm going to go for the deployment called gopinger and the namespace called default. I'm going to filter and I'm just going to pick single, well, only running nodes. Actually, just make it, I'm going to assume that they're all running. And I can take a random sample of size 1. And I'm going to go ahead and I'm going to kill them. And then immediately after that, I should be able to, again, retry this and verify that it's working. Okay, does that make sense to you? So yeah. I'm deploying a thing. I'm expecting to have 2 replicas. Then I'm killing one of them, and then I'm verifying that the service itself is responding correctly. That should hopefully work. Let's see if that does. F policy 2. Elevator music, please.
Well, is that going to work because you were editing in the text editor, not in VI?
I think it should because I moved this to the other one.
Okay. No problem. So we'll just wait. Yep, no copyrighted music, so we'll just sort of talk more about. Yeah, we can dance. Dance. Of course, I'm getting ready to sing a song that would probably get us struck. So no, I'm not going to sing the song. Okay.
Boom. Okay. So it killed the pod. We should be able to see it here. Actually, I should push that. Built our little pod, and then I tried to make a call. And the problem is that because it's a service, I actually didn't think that through. It didn't respond within the time. So I killed one of the pods, and I think we just had a lack of following on the pod that I just killed. That kube proxy didn't manage to actually reach at the time. So yeah, that's what I get for doing a live demo. So how can we work around that? Well, instead of
It's okay. Don't worry about it. I get the gist of it though, right?
Yeah.
Just don't let it be a service. Then things would have worked. So that's fine.
Yeah, exactly.
No big deal.
So yeah, that's probably more informative actually that it failed. Okay. Yeah, and the other thing that I was going to do is kind of show you the control plane. One of the interesting things that, depending how you run Kubernetes, you might or might not have control over the control plane. But if you do have control over that, it's a good idea to understand what happens when you lose one of them. So, for example, if we wanted to do something along the lines of save the policy 3. If you wanted to do something like, let me get rid of all of this. Boom. Actually, I'll take the action. I don't need no probe. And if we do something along the lines, I'm going to go ahead and I'm going to, what do I have here? So I have my API server minikube in kubesystem namespace. So if I go ahead and I kill that guy, so I'm gonna match namespace, kubesystem, and I'm gonna go and do property name, and do the kube API server. And I'm going to try to kill that. Boom. Let me remove this test. If I just change the name, test the control plane. With this pod action, I'm going to get all the pods from kubesystem. I'm going to select the one poor little kube API server. Then I could well, if I kill it and I only have one, it's going to go badly. But if I just give it, let's say, 20 seconds to restart, and this way I can verify that, for example, I can create something with kubectl. Kind of, this will confirm for me that the control plane is actually working. So let me run that, policy 3. Let's see how that goes. Policy is not valid. Property name, not valid. What did I mess up? Scenarios, steps, production, matches, namespace, filters, property, and name. If failing in them, names type string. Okay. So property name, actually, I just have example here. Property name and value is this. So like you can see, very easy to remember.
Name of name. Did I see that right?
Yep.
Okay, just making sure. Okay.
Yeah, just making sure. So I have the kube API server terminating, and if my cluster is any good, I would expect that after 20 seconds, it's actually going to come back and it's going to allow me to do a kubectl action. Let's see if that's actually the case. Whoop, looks like it did. So it created it and it deleted it. And just to kind of see, we got the thing from terminating.
Yep.
For some reason it didn't show us as starting, but I can see the gold finger showing up here, coming up and going down.
Yep.
So, yeah, so with a little bit of YAML and a few minutes, I can do a whole bunch of verification on my cluster. All right.
Cool. Thanks for spending a few minutes about that. Let's talk about the book.
Let's do.
Are you finished yet? Are you finished yet? Are you finished yet?
I have 2 more chapters to go. I have kind of left the Kubernetes one for the end.
That's what you
it's
said.
A large one.
That's what you said when we started. It's large. I know. I'm giving you.
Write faster. Write faster.
Yeah.
Do a course of fast typing.
It won't help.
No. Yeah, I mean, I'm kind of getting a little bit more motivated now to actually do the last push and finish off the last 2 chapters. I think I have a deadline for end of August to do that. I think that's pretty achievable. I also wanted to say that banner looks really professional.
Thank you. Well,
I like
it
that.
has nothing to do with me. It's all StreamYard. And by the way, you can get a discount code Pod Paradox 20 40% off. Go do it. Now, down in the description of this episode, if you're watching live, it's not there yet, but after, probably within an hour, all the description, all the links, all the everythings will be down in the description. So if you're watching this on replay, everything's down in the description. By the way, if you want to follow Miko, there's his Twitter handle. Miko, I'm still not going to attempt your last name. And honestly, I'm still not even trying to attempt your first name. I'm just thankful that you allow me to call you Miko.
That is fine. Don't worry. You're not the only one.
So your book is going well. You're wanting to be done at the end of August. It's coming out next year, right? Officially being released beginning of next year-ish. Q1, I think. What's the target date?
Yeah, I'm not sure how long it actually takes after you hand it in for them to produce it, but I think Q1 is the official one.
Okay. Now, and in case people, there is a free chapter. There is the 40% off. But hey, listen in. Hey you. Hey you, right there, right? You're the one, yeah, you. If you go back and listen to that episode 61, listen towards the end, there's a way to get a free copy of that book. Go listen to the episode 61. You have to do the things that are in that episode, and all of it's documented, but we're making you work for it. So you can go to the end of episode 61 of DevOps Paradox. The link will be down in the description as well. And we have codes. I'll just say it that way. We have codes. But you have to do what is in the episode. Did you get that?
I love that you explain it in that way, because you probably don't remember the steps yourself, but just do what's said there.
Yeah, because I don't remember.
Those things, yes.
That was weeks ago. But okay, so all joking aside, we have the discount code. There is a free chapter or two that are already up available on Manning. We have some codes to give away, but you need to go do the things to get the codes. Finally, and we have a limited set of codes, so once they run out, they run out. Now, let's talk about the book. You corrected me last time during the episode. It's not about PowerfulSeal specifically. So let's talk about what the book is about.
Sure thing. So the book is about trying to get you to understand that you don't need any of these fancy tools to implement your chaos engineering, and there's already plenty of different tools that you can use. So I'm trying to kind of cut through a lot of different stacks. So it goes from anything like, blocking syscalls on the operating system level, through poking with Docker. I'm going to kind of a lot of detail into how Docker is actually working under the hood, so that you can understand that and you can break some of the things and you can verify that they work the way you think they work. I'm going through things like JVM and injection of code on the fly with the Java agent stuff, so that you can do fancy stuff if you do work with JVM. And then it goes all the way to things like Kubernetes and PowerfulSeal, and even JavaScript, and seeing how you can inject failure in your JavaScript code. Surprise, it's not that hard.
Well, that's what I was getting ready to say, is that doesn't even seem like a challenge. It seems like that would be a very simple thing to do.
Yeah, so it's basically about demystifying the entire concept. And instead of just telling you, oh, go and use this tool, I'm trying to kind of give you all the background knowledge that you might need to have in these various situations that you're dealing with. And both from like running a platform kind of side, the SRE kind of role, but also application too, and how you can easily and cheaply add stuff to kind of increase your testing coverage. So yeah, I mean, there's going to be a plug on PowerfulSeal definitely when I get to the Kubernetes chapter, but it's just a small part.
Yep. And again, the title of the book is Chaos Engineering: Crash Test Your Applications. Look right down here. Look right down here. Right over there. I can't go over to where Miko is, because then I'll lose my hand. Pod Paradox 2.0, PowerfulSeal. Go look it up. Again, the link for this will be there. Now, let's talk about your newsletter.
So this is a little thing that I've put together recently. If you would like to get every few weeks, basically the news of the chaos engineering, whether it's about tools that are updated, whether it's about events or books that are upcoming, or whether you just want to see at some particular failures of people and their outages, go and sign up.
Go sign up.
For now, it's going to be probably fairly irregular from every maybe 2 to 4 to 6 weeks. And yeah, looking forward.
Cool.
So one question. There is that SIG group in CNCF for chaos engineering. I thought that last time I checked, you were involved in it, right? Or did I mistaken?
Yes, except that the group has kind of slowed down a little bit. I think we're kind of in the need of regrouping a little bit and seeing where it needs to go. But yeah, it's also a good place to get in touch with other people in the domain. It's a small world, isn't it?
It's a very small world. And we can't say any other words, otherwise Disney will come after us.
But I actually suspect that, I think that chaos engineering is still in very early stages outside of, Netflix type of stuff. Mm-hmm. My best guess is that we will see kind of software companies jumping into the train, just like right now they're in DevOps train that will probably explode in a couple of years in terms of solutions and offers and teaching and preaching and everything that comes along, I guess.
Yeah, that's my expectation too. That's kind of the bet I made by deciding to write that book. I think the main reason why I believe that's the case is because it's actually pretty cheap to do and it gives you good return on investment. So yeah, I expect to see more of that.
It's also, not necessarily cheap. I wouldn't say that, because if you do run it in production, then potentially you can do some not cheap damage, right? So it's cheap to kind of set up, right? But and it's very scary, I think. If you're talking about chaos in production, it's not scary to do it anywhere else, but
sure,
proving that you cannot disrupt real users by running something in production is usually scary.
Yeah, but that's where you apply all the other principles from, releasing the software. Probably not going to apply the same experiment to all of your production at once.
Exactly.
Again, that's something that, if you Google that, break things in production, probably don't do it as the first thing. But yeah, I meant from the actual time investment and money investment, the return on that investment you can get is pretty huge.
So this is interesting because maybe a week ago, I spoke with a company which I cannot name, and we were talking about different stuff, and one of them is chaos engineering. Mm-hmm. And I got the question, and I'm going to pass it to you just to see the answer, because I was so confused that I couldn't think fast. What is the return of investment of doing that if you have a system that hasn't failed for 20 years?
That question.
That question, yes. What is the return of investment?
Yeah, it's kind of like, security through obscurity, because no one knows how it works. No one will probably, maybe, who knows, perhaps break into that. Yeah, if you just jump into chaos engineering, probably taking a legacy system that's older than you might not be the best idea to start with. But I have seen systems where, people had no idea about their SLOs, kind of, the expectations of how long things would take or should take, and just kind of the verification bit of it, of a kind of live system without doing anything particularly dangerous or anything particularly dramatic to the system was already producing value, because knowing your system, that might be very legacy, that's already value. But yeah, that's always I'm gonna, that's a gotcha question. Let's see what they say.
I interpret it as one of those questions, when you're asking intentionally the question to defend status quo type of, I'm going to ask you. So we're NoSQL databases are not transactional, stuff like that.
Yeah. I've heard this question before. Pretty much at every presentation that I ever gave about this.
My answer, the best answer I could come up with was, I haven't had a car accident for 20 years also, so probably I shouldn't wear a seatbelt.
Yeah. Mm-hmm. Or get my brakes checked out, or
exactly,
or change the oil, or
exactly,
replace the hoses or belts.
Yeah, that's funny you brought up this example, because that's kind of similar to the one that kind of starting in the first chapter of the book, is that it's chaos engineering in many ways is kind of like the crash testing of the application of the automobiles. That pretty much I think every new car that makes it to the market has to go through this amazing videos where you get like all this slow-mo, high-resolution video of the thing being smashed, and the dummies inside getting their heads and limbs ripped out and flying through this kind of rain of broken glass. And that's really what we're after here, this kind of controlled environment. We can see things. They don't do them with real people necessarily, but they do that to every single car. And I think that's pretty illustrative too. So next time they ask you that, you have another example to another parable to give them.
Exactly.
Okay. By the way, we haven't done our shameless plugs yet. If you haven't filled out the survey yet, go fill out the survey. Victor is currently working on Lambda.
I'm finishing the function as a service.
Yep.
And maybe it will be more serverless after that, like container as a service, maybe something else. We don't know.
That's what the survey is there for.
It's a mystery.
It is a mystery. And by the way, if you haven't joined up the Slack channel, go join up on the Slack channel. If you're taking our episode 61 challenge to figure out how to get a code, you're going to need to know you need to be in the Slack channel. That much I do remember. So go ahead and do this to get ahead of yourself. Finally, if you are interested in any of our books or courses, there's the website there. I was pointing with my other finger that wasn't even pointing on the screen. We're about at the top of the hour. For people who have hung out this long, thank you for hanging out. Miko, it was great seeing you again.
Thanks for having me.
Let us know when your book is done. We'll bring you back on, and maybe we can do an unboxing with your book. That means you can't actually open the box.
No, we should do, like for novels, when you go to a shop and then you do live reading. Chapter 7.
Good. Well,
Chapter 7.
Yes, that would be interesting. Interesting may be too strong of a term. That's interesting and honor. When people come on here and it's like, oh, it's an honor to talk to you. I went, I don't think you understand what that word means. So it could be interesting, but yeah, we could do a reading.
That would be cool. Listing 7.1. Import RE.
Exactly. Pick the one that is mostly commands and source code. The one that has the biggest output.
That has to. Do you have any YAMLs in the book that end up being over like 5 pages? If not, you should. The editor will love you for that.
No, I've been really trying to keep it small, but yeah, it's still gonna be fun. I think the longest one is about a page long now. Should I ramp it up?
How do I copy this out of here? I can't get.
I need to space it out a bit. Yeah, unfortunately, they don't pay per character, so
no,
defeats the purpose. Exactly.
All right. Miko, thanks for hanging out again today. Have a great weekend. Victor, see you later. If you're in the US and you're watching this live, July 3rd, tomorrow's July 4th. Keep your dogs inside. Don't let the fireworks freak them out, or other animals that may get freaked out by fireworks like me. I will be under pillows and comforters tomorrow. So that's another episode for another day. All right. Thanks, everybody. See you again.
Thank you.
And hopefully next week.
Thanks for having me.
All right. Thanks, Miko.
See you.
Cheers.